Okay. Don't forget, you guys are going to need a ruler for the test tomorrow. All right, so today is the 13th. Chapter 4, test review. Page 287. All right, let's start with our chapter review. I think our first one was 14. So go to 14. Okay. So a bus leaves a station. Who asked me for 14? Okay. So the bus leaves a station, leaves at 10 a.m. to take students on a field trip. All right, so we have a bus, leaves 10 a.m. Okay. So then it says at 10:25 a.m., the bus is 100 miles from the site. All right. Then they tell us at 11:15 a.m. the bus is 65 miles from the site. All right, the bus travels at a constant speed. Why is that important? That they say the bus is traveling at a constant speed. Al? Yeah, but more importantly, what could I not represent this situation as if it's not a constant speed? Joseph? There wouldn't be a slope, right? So this would not be a linear relationship. All right, so this statement indicates that we have a linear relationship. If I didn't have that, I would either have to assume that it is, or I would simply say, I can't do this because I don't know if the speed is constant, okay? All right, so we know that. Write an equation in point-slope form that relates the distance. Now, this is really important. We want to relate the distance from the site and the time in minutes. Since 10 a.m. That's really, really, really important. All right, if I do not recognize that, I think, Joseph, that's what you and I were talking about on Friday. If I don't recognize this, that this is what the information stands for, my distance from the site, that's what my miles are, and my number of minutes since 10 a.m. Well, then the number of minutes since 10 a.m. has to be my x, because that's what's changing. And my distance from the site depends on how many minutes I've been driving. So that has to be my y. All right, and I know that, so I'm going to say distance from site depends on how many minutes I've been driving. That's why the number of minutes from the site is y, the number of minutes driving is x. Okay, so now that I've done that, that's when we realize up here, I've been given two data points. So actually, this goes back to a point slope one, okay? So now that I've identified I have a linear, I've identified what my x and y are, even if it didn't say write a point slope form, I could, because I recognize I have two random data points. Is one of those my y-intercept? Is one of these two data points my y-intercept? And if yes, how do you know? If no, how do you know? Rita, what do you think? So what would so this would be 25, 100, and this one here would be, what'd you say? 75? Excellent. What would my y-intercept look like? So what time would that be? It would be 10. So if we knew at 10 o'clock how far we were away from the site, that would be our y-intercept. Because you're right, our y-intercept is when x is 0, and that would be the number of minutes since 10 a.m. would be at 10 a.m. All right, so I don't have my y-intercept. So I have two data points. So at this point, they told us to put this in slope-intercept, in point-slope form. Typically, these are put eventually into slope-intercept form. Either way, you can start with point-slope and leave it, or you can turn it into slope-intercept if they don't tell you. All right, on your test, I'm going to want you to put these in slope-intercept form, okay? So now that I have I know what x and y stand for, I know my two data points, I want to do point-slope form. So point-slope form requires the slope and 1 point, but here I don't even have my slope, so I have to find my slope first. So this is y minus y1 is equal to m times the quantity of x minus x1. So I need to find my slope. So that's y2 minus y1 over x2 minus x1. So I'm going to do 100 minus 65 is equal to 25 minus 75. All right, so if I have 100 minus 65, this gives me 35 over a negative 50. All right, I'm going to turn that into a rate. All right, because this is miles and this is minutes. All right, so 35 divided by 50, my slope is a negative 0.7 miles per minute. That's what my slope means, and I would expect you to know what your slope means. All right, so now I'm just going to go ahead and put it in here. Now the thing with point-slope form is you could use either one of the 2 points, data points you were given. It doesn't matter which one you use. So if I use 25, 100, my equation would be y minus 100 is equal to negative 0.7 times the quantity of x minus 25. So, Maya and Ashley, does that help you? Yes, please. Okay, so what does y represent? So, as we are getting closer, isn't that distance going down? That's why. It's like the one with the bagel, right? You've got your gift card, and you're subtracting off every time you buy a bagel, which is why that's a negative slope, because we're subtracting it off. I like that you're trying to make sense of it. That's really smart. And that's why we're taking off miles the closer we get. So that has to be a negative miles taken off. Does that make sense? Okay, awesome. All right, so that was 14. Let's take a look at number 15. Ashley, does that help you as well? Awesome. All right, so if we take a look at number 15. 15 said the directions were write the equation in standard form. Yeah. Yeah. No. That's a good question. Nope, as long as you can either do either one of those. So if you put it in slope-intercept form, you have to find your b, right? If you put it in point-slope, you just have to solve it, do whatever you have to do to get it into the right form. Good question. Does anyone want me to do 15? Okay, somebody asked for 16. Who asked for 16? Okay. So if I take a look at 16, it passes through -1, -5. And 3, 7. So for me to turn this into standard form, I have to write it in either slope-intercept or point-slope form first. All right, so I'm first going to start with my slope, y2 minus y1 over x2 minus x1. So I'm going to do 7 minus a -5 over 3 minus a -1. You guys catch me if I'm making a mistake, please. This is 12 over 4, so my slope is 3. So, Maggie, did you use point-slope form or did you use slope-intercept form? Okay. So which point did you use for point-slope? Excellent. All right, so I have y minus y1 is equal to m times the quantity of x minus x1. So that would be y minus 7 is equal to 3 times the quantity of x minus 3. And now I'm just going to do the distributive property and start putting this in standard form. So I have y plus a negative 7 is equal to 3x plus a negative 9. I'm going to move my 7 first. I'm going to add 7 to both sides. So I get y equals positive 3x plus a negative 2. I'm going to subtract 3x from both sides. And I get negative 3x plus y is equal to negative 2. Now it is possible that theirs, this should be an x, not a y, it is possible they had positive 3x minus y is equal to a positive 2. I'm going to say or here. Either one of those work. The first one, I brought x over to the side with y. On the second one, you brought y over to the side with x, and then my constant off by itself. So either one of these I would take as correct. Okay. Yep. You're welcome. All right, let's take a look at 18. Who asked me for 18? You did. Excellent. So 18, do you want me to do parallel or perpendicular or both? Perpendicular? Okay. So they tell us we want, our point is 0, 2 that they've given us, and they've given us y equals negative 4x plus 6. All right, so the only thing I need from that given line is that slope. All right, because I'm writing a line that is perpendicular to this line. So my slope here is negative 4. So Carmen, what is the perpendicular slope to that? Positive 1/4. Now the really nice thing is, they've already given us our y-intercept. So there's really no work that I need to do to find my b value. How do I know, you guys, that that's my y-intercept? How do I know that this point is my y-intercept? Seamus? I'm sorry? I can't hear you. Why? How do you know that? Put your hands down. Yeah, because of that 0. Right, that 0 in my x, that tells me it's my y-intercept. So I have y equals mx plus b. So I have y equals 1/4 x plus 2. So when you're finding parallel and perpendicular lines, make sure you're putting them in the same format as your given line, which is usually slope-intercept. This one here? That usually does, because people are like, oh, isn't that my y-intercept, right? They take that as the y-intercept. But the thing is that the only thing we need from this given equation is the slope. That's it. Okay? All right. So that was 18. 22 is my next one. Okay, so 22. All right, so who asked me for 22? All right, so this was my table that they gave, my graph that they gave us. So all you needed to do, they said for 30 pounds, so I'm going to freeze this. Okay. So they wanted to know for 30 pounds. So what you need to do for this is you've got to kind of figure out where 30 pounds is, right? So if I take a look at this, so if I'm counting, you can kind of see what we're counting by. So we're counting by fours. This is 16. This is counting by fours. 16. Seriously. That's 8, 12, 16, 24. You need to extend your table. Okay? So once we extend our table, we have to get it out. That's 24. This is 28. 30 is going to be, this is going to be 32, right? Right? Did I do something wrong? points doing one thing, and what's a couple steps ahead, 24, 28, 32. So I would need to extend what they gave us.
I got 6 instead, and I can't figure out why, because I think their answer was 5.25.
Okay, so let's take a look at your guys' graphs. Since this does not extend all the way out, let me use somebody's as my guide. Can I take yours? Awesome. So remember that this is an approximation, but it should be pretty close based on what you have. So if I take a look at this, so Molly extended it out. So here is 32, so it's approximately somewhere in here. It's probably halfway. I like that it's halfway. I'm just reading up. This is 1, 2, 3, 4, 5, 6, right? I would say pretty close to 6, if not right at 6. All right. I don't know how they would have gotten 5.25.
Maybe it was just because, like, maybe you didn't draw the line of it exactly.
Yeah, I don't know. I mean, again, it's an approximation. All right, so I do agree with 6 for yours. So this is what I'm going to be looking at. I am going to be looking at, now they gave us the line of best fit, okay? But I would be looking at, did you choose the right points for your line of best fit if you were writing it? If you did could you make your line, draw your line all the way through it? And then, did you read yours properly? If you used it and read it properly, whatever you got for your answer is your answer. Does that make sense? So it might be off from mine, but as long as it makes sense based on what you did, it's correct. Is that good with you guys? So you guys kind of see it's not going to be perfect when you're using these graphs? Okay, so then you guys asked me for standard form. Elle, was that you? Okay, so when you're talking about standard form, are you talking about be more specific. Are you looking for how to write a standard form equation given data? Are you talking about story problems? Okay. So when we're talking about standard form, what you're looking for is you look for 2 rates and you look for 1 total. So you look for 2 rates and 1 total. All right. So your book does not have a ton of problems in it. So sometimes I go to the other book. So let me jump to the other book. So they don't have a ton either. Okay. So let's say, here's an example that I have. So let's say we have an average person burns 7 calories per minute hiking, and 10 calories per minute biking. If they are looking to burn 500 calories doing both together, doing both activities together, what are 3 possible combinations of time spent on each? Okay, So when I take a look at this, I have two rates here. How many of you guys notice I have two rates? All right. We also, and they're dealing with number of calories per minute. I've also been given the total number of calories I want to burn. This is a standard form equation. I don't know how many calories, I don't know how many minutes I'm hiking, I don't know how many minutes I'm biking. One does not always depend on the other. In slope-intercept form and point slope form, your y is always your total amount of something, total amount of money. Here, and it's always missing. Here, in standard form, you have your total. All right, so all of you do this, please. To find your possible combinations, you have to graph it. So let's at least get to our equation, okay? Always identify what X stands for and always identify what Y stands for, please. So I made X my number of minutes hiking, Y my number of minutes biking. Don't just write hiking, because I don't know if you know what that really means. It's number of minutes hiking. So Ryan, what would be my equation here? Excellent. How would I graph this? What is it that I'm finding for me to be able to graph it? Rafaela? No. I do not allow you to change this into slope-intercept form to graph it. You have to know how to graph from standard form. Ryan? Yeah, you have to find your x and y intercepts. So I should see your work off to the side, find your x-intercept and your y-intercept. Remember, your x-intercept is when y equals 0. Your y-intercept is when x equals 0. And you're just going to round this. I'm just going to say 71 minutes. So this would end up being 71, 0. Don't forget to put that y-intercept and x-intercept as two different coordinate points. And you graph it. Okay, I don't know that there's other ones that we want to do, so I'm not going to make you graph that. From there, you graph it, and then your possible combinations are just reading your graph. Are you guys cool with that? Okay. So the hard part, and just the part I wanted to focus on, was writing the equations, and then remembering that you need to find your x and y intercepts. Are you guys cool? Okay. So I don't want to forget the other things people have asked. So you guys also asked me for page 226, starting with, or 226, number 46. Oh, look at that. All right, so let's look at number 226, or page 226, number 46. Okay, so 46 said, a camera shop charges $3.99 for an enlargement photo. So it's $3.99 per enlargement photo. All right, enlargements can be delivered for a charge of $1.49 per order. Write an equation that gives a total cost with the delivery. So we want total cost with delivery as a function of the number of enlargements. All right, remember, when you have this phrase, you're like super, super awesome that you have that phrase. Because first of all, that says we want slope-intercept form, y equals mx plus b. That's the first thing this phrase tells us that we want. This also indicates what x and y stand for. Remember, y as a function of x. So x is my number of enlargements, y is the total cost with delivery. Now I'm going to go back up here to kind of figure out what I have. If x is my number of enlargements, what does that mean $3.99 is? If x is my number of enlargements, what does that mean $3.99 is? Lily? That's our slope. Because it depends on my number of enlargements. There's my slope. What then is this? The delivery. Joseph? That's my y-intercept. Why is that my y-intercept? It is a one-time fee. It doesn't say $1.49 per enlargement. It says for an order. And we want to know the cost of an order, one order with delivery. So there's my b value. All right, so I have y equals 3.99x plus 1.49. All right, and then in 46 it also said find the total cost of 8 enlargements. So when x is equal to 8, we want to know the total cost. All right, and when we do that math, we should get $33.41 if we did that right. Who asked me for that one? Awesome. Are you cool with that? Excellent. All right, the last one you guys asked me for was page 278. Let's see if I can talk about that one real quick. Start at 278, number 19. Don't forget, you may have to beat up tables to determine if they're linear. All right, they tell us to, who asked me for this one? Okay, so they asked me to make a scatter plot on it. I'm assuming you understand how to make the scatter plot. Are you cool with that? Okay, so we make the scatter plot. I'm just going to run through this really quick. Here's a scatter plot from this problem. All right, so if I'm looking at this, what? What? Okay. All right, so if I was to look at this scatter plot, I probably might choose that top value and maybe one of these in the middle there. So I can get, I don't even know, this one's tight. I probably would use the top value and the bottom one. That way these here are kind of a little bit below it, and this is these two are a little bit above it, is probably what I would do from there. Is I would use that top one and that bottom one is probably what I would do. Does that make sense to you guys? That's really subjective, and I will not be that picky. Okay, especially when they're this tight. All right, Molly, do you need me to do anything else on this one? All right, because it said write the equation, and then they gave us, so we just find our slope and then find our y-intercept using those 2 points. All right, and then we would just use it in part C. Are you cool? You're definitely having a problem like 19. So you're definitely having a scatter plot that you have to make, and then you have to write an equation of line of best fit and then use it. You're definitely going to have one of those. You know, you're going to have a story problem for standard form and a story problem for slope-intercept form. You might have a beating up of a table to determine if it's linear. Parallel and perpendicular lines. Okay? Basically, that's it. Yes? If I have you do it point slope, you're going to have to turn it into slope-intercept. So, again, point slope is not it's not really a necessary one. It's just, it's handy to be able to use it. So I may give you an equation, that will have, or a story problem that you could put it into point slope and then turn into slope intercept, or you can put it in slope intercept and find your B value. You know what I mean?
Yeah.
Okay.